idea is to try to test fractal alpha, this model. I have no idea from where this model come, but let's try to evaluate it, because I found some of the things that I tried, it gave me quite good answers. So let's, for only for comparison, let's try to put another model, another basic model around it. Let's look at ChatGPT, but let's look at the GPT-4o mini as a comparison for a decent model, if you can tell it. And let's show you for also comparison. Let's look at another one. Let's look at here at a good model. Let's look at a good model. Let's take Sonnet, and Sonnet from not the last Claude 33.5, but the Sonnet from June. So let's start to look at something that usually models that are not the best gets wrong. For example, which ligaments are torn in medial patellar dislocation? Why this question is very hard for LLMs, and not just for LLMs. If you take this question and you post it in Google, it will also give you a wrong answer. The reason why it's so hard for this is not true. Why it's so hard, and this also from Gemini, this is not true. Why it's so hard? Because this is very, very, very unusual pathology to get a medial patellar dislocation. Your patella, if you look at the patella, usually it gets dislocated laterally and not medially. So all the literature is from the internet is about a lateral dislocation. If you look here, the patella, and this is the tibia. I'm not sure where is the fibula, why I don't see it. It's not very good. Oh, this is much better image. So if you look at the image, this is the tibia, this is the fibula, so this is the lateral side. You see, even I asked about medial patellar dislocation and Google gave me the wrong answer with the wrong image. This image show you a dislocation of the patella to the fibula side. This is the lateral side. This is not a medial dislocation, because all the literature talks about lateral dislocation. This is because usually the patella is torn to the lateral side, not the medial. And when this happens, the ligament that is torn is almost always the medial patellar dislocation, the MPFL. So all the literatures talk about MPFL tear. Now, when you ask, for example, GPT-4o mini this question about medial dislocation and not lateral, and when you look at the ligaments, it's quite hard to see it, but if you will have all the ligaments, for example this one, if you look at the ligaments, you will see that the lateral patellofemoral ligament is the one that will be torn when this patella will go to the medial side. So the answer should be lateral patellofemoral ligament when the patella is dislocated to the medial side. Again, it's very rare, so it's very hard to understand it. And when you ask GPT-4o mini, it tells you MPFL, MCL, not true. This is torn. Those are the medial side ligaments, so they are torn when the patella will be dislocated laterally. So when we are talking about medial patellar dislocation, this is not what will be torn. What will be torn, if you ask this question for a better model, for example Claude, the answer that I expect him to give me is the lateral patellofemoral ligament, which it usually gets it right. You see here, this is the right answer, LPFL, and it's very not easy because most models, even GPT-4o, sometimes they don't get it right. Maybe I'll show you this. Now let's test this fractal alpha new model, and it seems like it's thinking, but I'm not sure it really thinking, because Gemini in Chat Arena also do this thinking idea. But you can see its answer, it's quite a good answer. It starts with telling me that it's relatively rare compared to lateral patellar dislocation, which is totally true. It started with telling me about MPFL, but it tells me that actually in medial patellar dislocation, the structure analogous to this, which is crucial for preventing lateral dislocation, is not the primary ligament. Instead, the focus shifts to the structure that would normally prevent excessive medial movement. He understood me. Even Google don't understand that. Google, this, I just posted in Google and this is wrong. Now it tells me about the LPFL, which is totally true. This ligament, along with other lateral stabilizers, can be injured in a medial patellar fit dislocation because the patellar abnormal medial shift would put stress on the structure. This is the right answer, and it answered again, as before, the right answer for this. And this is quite hard for LLMs to do that. If I even take this and post it in a, I don't know, GPT-4o, so let's go, oh, I get, okay, so you saw Claude for GPT-4o, never mind. Let's continue. Let's now look at how it codes some games. So please give me code in Python for snake game. Now, until it gives me the code, I'm not sure which model is it. I'm not sure from where it is. I saw this from Meta, but some other user got different answers. I'm not sure how many parameters are there, but let's look at the code. The code is not the best, will be, but it's a decent code, should be. You can see the speed of it. It seems, I don't know if it's thought before. I don't know how it's so good at answering the questions, but okay, this is the game. Now, if you look at the game, this is Snake, and it works, but it doesn't give me the best, I think. I mean, you don't see the scoring. It starts moving before I even touch anything, but and when I'm finished, it doesn't tell me. It just starts another game. I'm not sure it's better or not better. Maybe it's a good thing. It just tell me here the score, game over and final, and this is what happens, and start again automatically, which is nice. It works. And now let's do another test in computer science, and a test that some LLMs get wrong. And the test is trying to understand binary numbers and how to convert them between bases. For example, some LLMs get it very hard, or not very, but some LLMs get it bad to translate between binary numbers to hexadecimal numbers. For example, if I take this number 110000 11111100, so if you want to convert this from, let's say that it is a hexadecimal number, yes, like this, it's hexa, base of 16 hexa, and I want to convert it to binary, what I need to do is to take each 4 digits and convert them to binary. So if I take this number 1 2 3 4, no, 1 2 3 4 1 1 2 3 4 1 2 3 4 1 2 3, let's add something, so it will be 4. Okay, now I should do like this, should do this one, and then okay, let's separate, just to separate them so I can translate, and you'll see how I translated it. Okay, so now after I did this, I can translate each group of 4 to a binary, oh, this is from binary, sorry, from binary to hexadecimal. So I need to divide them to groups of 4 and then take that. And this one is 2 to the power of 0, 1 and 2, which is 1 plus 2 plus 4, which is 7. So it's 7, and then in hexa, so let's do, this is not hexa, let's do 0, x, and then 0, and then f, because this is f, this is 15, and this is 8, right? 8. So this is the number in hexadecimal. Let's try to give it to the model, but without this it will make it harder, so it won't be really divided by the 0. The model should add this 0. Let's try to give it to GPT-4o mini, and for this and for Claude, let's see if take this number which is in binary and convert it to hexadecimal. Oh, maybe I should take this so we can remember the value. Let's put it right over here where I'm at. Okay, so let's see if we can do that. Binary, convert it to hexadecimal, please. not, I won't tell him to show me. I want him will do it himself. And now, until he do that, let's take it and put it to, let's see, GPT-4 or Mini. How we convert this. Now, let's see, 0 here, and this is 4, and this is 4. You can see here that it took 1, 2, 3, 4, 1, 2, 3, 4. Oh, 1, 2, 3, 4, 1, 2, 3. Oh, you see, this is the problem I talked about. If you look, we have, this is 4, great. Now you have another 4 of 1s, great. Now look what he did. He took this one, but we already used it, and put it right over here in order to get 4s. But this was the idea. He should have added in the end another 0. He didn't do that. Here there is 4 zeros. He add this one. It shouldn't. It should not have done that. So this is not true. This is not true. Right, let's check again. This is 4. This is great. Now from here, this is 4. This is great. Now you have 0, but he put here 1. This is not good. This is a fail. Now let's show it to Claude. Let's see. Claude is not the best in it, I must say. Let's see how Fractal did it. Maybe he also made it wrong. And it seemed that he also did it wrong. 1, 2, 3, 4, 1, 2, what? He add a 0 to the right. He added a 0 to the right. This is not true. This is the idea, to break it to 4 binary group and then convert each group. This is good. Group the binary numbers into sets of 4, starting from the right. He also started from the right place, but this is 1, 2, 3, 4, and this is not the 4 that right over here. He did it wrong. This is a fail. And now let's take it to Claude, and this is sometimes even hard for Claude to do. Let's see if he can take it. Okay. And Claude did it also wrong. This is not true. You have here 3 zeros. Why? It did the same as Fractal. Let's now try to take the newest Claude and see how it goes here. This is also wrong. Okay, let's try to take GPT-4 latest and see if he gets it wrong. For now, no one of the models. Let's see if this one, binary group of, this is also not true. Should take 4 from here. You didn't do that. No model can do that. I don't have 1. Yes, I don't have those. But even the newest Claude, the newest Sono 3.5 didn't do that. So this is maybe too hard question for LLMs. You could take Gemini. Gemini should be quite good in it. I must say that Gemini usually are quite good in it. Let's try Gemini. The newest one, quite good at those questions from my experience, so maybe he will do that. And Gemini did it. It seemed that he did it. But, oh, he added a 0 right over here. It did the same as Fractal. I'm starting to think that I'm the one who is making the mistake, but I don't see how. Because if you look at this and convert this binary to hexadecimal. Enter a binary number, convert. This is the number, and this is the number I calculated. So all the models, including Gemini, including GPT-4o Mini, 4o Mini, 4o latest, Claude New, all of them did it wrong, and what I did was right. So this is wrong, everything that the other model. Okay, so converting from binary to hexa is quite hard when the number is not full for LLMs. Fractal also did it wrong, but what can I say, other models also did it wrong, so maybe it's okay. Okay, now let's try to see if the model is quite up to date. Another question that is quite interesting is to see if the model knows how to treat, for example, gonorrhea infection, which should be with the latest CDC recommendations using ceftriaxone 500 milligrams IM plus doxycycline 100 milligram 2 times for 7 days. If there are no other contraindications and there are nothing else, and you should add doxycycline to cover chlamydia. And I want to see if it tells me the latest and most recent CDC guidelines. Now the problem with this is that sometimes if I ask this GPT-4o Mini, it gives me quite a good answer. I mean, not always. What is the treatment for gonorrhea infection? Now it should understand that I'm talking about ceftriaxone 500 milligrams and 1 milligram of azithromycin to cover chlamydia. Today is more likely of doxycycline. Okay, but sometimes it gets it wrong. Let's see that just this model gets it right. Let's see. And how much it tells me about the other things. Now I'm not sure if he's thinking right now. What is going on? Maybe he does, maybe he doesn't. I'm not sure. But when he gives me the answer, as you can see here, let's see. So CDC is 500 milligrams intramuscularly plus 1 gram of azithromycin, which may be better if he told me doxycycline. Allergy, co-administration, he talked me about chlamydia, even though I asked about gonorrhea, which is good because you need to treat the co-infection because it is common, and he told me about it, which is quite good. Those recommendation, it's more commonly you can use, and sometimes it is told that azithromycin, but usually the most recent update that I know is from CDC, which use doxycycline, but most of the model tell you doxycycline. Okay, it's a good answer. Maybe it's because it's not totally updated. Okay, so yes, so this model seems quite good. You can see in the programming that is quite good. I want to think about another question. Oh, of course, another question is to tell me about the anatomy of the vertebrae. There are vertebra anatomy, and why I want to ask it, it is because there are many structures that the LLM can just ignore and don't tell me. And what I want it to tell me is not just the vertebra bony structures, but also the ligaments. You can see here the ligament, and if you will see a more precise and more detailed image, you will see that it has ligaments. And now you can see how hard it is to find such an image, but I will find it. Don't worry, I'll find it, or I'll just write it with ligaments. Okay, now this is good. This is a good. This is a good one. Now, okay. Now you can see that there is the anterior longitudinal ligament, posterior longitudinal ligament. Here is the ligamentum of flavum. Here is the interspinous ligament. This is the supraspinous ligament. So you can see that there are ligaments, and those ligaments are part of the anterior and posterior compartments of the vertebra. Now you can ask the LLM about this. For example, what are the structures on the vertebra in the anterior and posterior compartments? And then you can see that it tells me about the vertebral end plates and anterior longitudinal ligament. It doesn't tell you all the time about it. This is quite a good answer, I must say. Okay, this was a very detailed answer. Usually it doesn't give me quite a good answer, but this was good. It told me about almost every ligament that I need to know about, the most important ones. Let's see how it tells me about it. Not sure he is thinking. What is going on here? Okay, so let's see. Cervical region, trachea. I talked about the vertebra. Okay, vertebral body in the vertebral disc, anterior. Okay, this is the anterior compartment structures. Okay, prevertebral disc, visceral. Okay, posterior compartment, posterior element, pedicel, transverse process, lamina, spinous process, articular process. This is good. Posterior longitudinal ligament, ligamentum flavum, interspinous, in intertransverse ligament. What is intertransverse ligament? Okay, he really make it very detailed. He even talked to me about the muscles and okay, and the spinal cord, which is of course in the side of the posterior part. What is inter? This is real. Let's see. So this model is quite detailed. There is such a ligament, and it seems that it is in the between the pedicles. Okay, you can call it in the posterior part. Quite nice, quite detailed. So this model looks quite good, I must say. I'm not sure if I will like it if I continue to use it. Oh, there is a very hard question. I must ask it. This is about in diving medicine, and in diving medicine there are charts that tell you how to treat, and now there are tables for the from the US Navy that tell you how to treat each type of a diving how do you call it, decompression sickness. So there are decompression sicknesses that should be used and treated with table number 5 and table number 6. Now usually the model, the LLM, can't tell me what is the table, so let's see if this one can. What is the treatment protocol in table 6 of the US Navy for the treatment of decompression sickness? Okay, this is very hard question. I had no model, I think. I don't remember any model that gave me the right answer. Let's try to give it to another model, Claude, the newest one, which is a very good model. So let's see the answer here. And this answer, this is table 6, right? You need to go to right, oh, stop it. This is great. You need to dive to this deep with this. This is exactly this is of Claude, yes? Claude is good. Now this is for decompression type 2, type 1. Okay. And arterial gas emboli is true. This is the pressure. This is the oxygen intervals. It's important intervals between every 20 minutes you need 5 minutes of air. This is exactly the time that is needed. Now compression 2, this is good. Period of 20 minutes, and then Oh, the patient breathed at 3 minutes sooner with air breaks between. It doesn't tell me how much time they break, but this is true as I remember. Ascent, we're continuing. Two additional, this is true. This is a very good answer, very good answer. Okay, not many models gave me such a good answer. Claude, the newest one, gave me a very good answer. Let's see this one. This is true, this is the total time. Air brakes, this is true, but it doesn't tell me how much. This is not as good as Claude. You are going to this deep. You do brakes, but you didn't tell me how much. Mm, this is okay, but very, very not like. You can see GPT-4o mini. I don't think you will know. You can see the answer. This is not. This is not. No, no, no. This is not a protocol. No, you are going to 60 feet, but you are not going there for what is type grade 3. Okay, for 30 minutes you are doing. No, you do what Claude says, not this one. This is not good. This is not good. So this fractal is between GPT-4o mini and Claude. And Claude, I think, the only one that gave me such a good answer until now. Oh, wait, I asked GPT-4o. Oh, sorry, this wasn't Claude. This was GPT-4o latest. This is a very good answer for GPT-4o latest. I'm not sure that Claude did it. But if you look at different model, for example, GPT, I thought I asked GPT-4. Okay, Claude, let's see Claude. This is not good answer. This is the newest one, right? And this is not a good answer. I mean, this is too. This is even. Fractal did a good compared to Claude, but GPT-4o latest did the best. This is okay answer. This is like the newest Claude, but GPT-4o latest gave me the best. Okay, so this looks like quite a decent model. He knows quite good things, and he not going to traps when I ask him about very rare things like I did with medial patellar dislocation. In coding, it gave me quite okay, and another questions. It's quite a good model, it seems. I mean, not very not as you saw, not every model can give me the true table, even though not the total protocol. Not every model. Okay, coding is okay, and not every model can give me about the medial patellar dislocation or about the posterior and anterior parts of the vertebra, this in details. So it seems quite good model. He also knows treatment protocols, quite good model from this very, very shallow and very compressed or easy, or not easy, but very short tests. Thank you very much. Maybe you will have an idea what is this model is, and this is it.